video, let us discuss about NLP, data pre-processing, right? So let us try to understand this. So in the first step, what I have done is I have imported NLTK. NLTK is nothing but natural language toolkit. From NLTK, I'm downloading this PUNKT, right? So I'm downloading this package basically in case if you get the output as true, then our work is being done. So the next step, what I'm doing is from NLTK.tokenize, import sent underscore tokenize, comma word underscore tokenize, right? So let me tell you that what is happening over here, right? So sent underscore tokenize means what it will do is when I give some paragraph, that will be converted into sentence, that will be tokenized into sentences, and the sentences can be tokenized into words. So look here, so I have a text over here. Text is equal to natural language processing is a field in artificial intelligence and is related to linguistics. On a high level, the goal of NLP is to program computers to automatically understand human languages and also to automatically write or speak in human languages. We say natural language to mean human language and to indicate that we are not talking about computer languages. Let us study the pre-processing steps in NLP. We need to know about the libraries for NLP. So let me run this code and I'll show you like what is happening now. Just I want to see the type of text. So it is saying that it belongs to the type string, right? So in case if I want to get the length of this text, so what is the text over here? This text, right? So I want to get the length. So what I'm getting is 485, right? So what I'm doing now, send is equal to send underscore tokenize of this text basically. So I'm rewriting this sent again and print of send underscore tokenize of text. So what is happening over here? Just you can look at the code now. Natural language processing NLP is a field in artificial intelligence and is also related to linguistics, right? So this is basically one sentence. The second sentence, what you can see, on a high level, the goal of NLP is to program computers to automatically understand human languages and also to automatically write or speak in human languages. So this is basically the second sentence. The third sentence I'm getting, we say natural language to mean human language and to indicate that we are not talking about computer programming languages. Let us study the pre-processing steps, right? So this is what happening over here. So now what I'm doing, I'm going to tokenize these into words. So what I'm writing, words is equal to word underscore tokenize text. So when I get the output, what I'm getting, natural is separate, language is separate, processing is separate. So basically I'm getting tokens that are nothing but the words, right? So what I have done is say from NLTK dot probability import freq-dist. So basically I'm trying to get the frequency distribution of words and what are the most common. So from this, what I could figure out is 2 has appeared 7 times and this comma has appeared 4 times. NLP has appeared 3 times, if has appeared 3 times, in has appeared 3 times, right? So now I'm importing matplotlib.pyplot as PLT and just I want to see the plot of this. So what I can see over here is for 2, I'm having 7 and basically for this comma, I'm having 4 and NLP I'm getting 3, yes, also I'm getting 3, in also I'm getting 3, right? So now what I'm doing, no punk. Okay, so basically I'm creating an empty list now. I'm creating an empty list now. So for W in words, so I'm creating a for loop now. So if W is alpha, no punk dot append W dot lower, print no punk, and here this is to create a new line and I want to also get the length of this no punk, right? So what I could see over here is like a natural language processing. So what is happening? If you look over here, you could see a lot of pronunciation over here, but now those are not there, right? So what is the output now? Output I'm getting it as 73 now, right? So then now free f dist equal to freak dist no punk f dist dot most underscore common. So what I'm getting now, so here I had a comma. Now I'm not getting that comma. So what is happening? 2 is 7 and then NLP is 3, S is 3, in is 3, the same thing I'm getting, and also language is 3. So what has happened over here? This comma is being replaced since I have removed those punctuations. What I'm getting is just, other than that, what is the next one which has more frequency? So the model is identifying the language, right? So from NLTK dot corpus import stopwords. Stopwords equal to stopwords dot words English, print stopwords. So what I'm doing here, I'm trying to import these stopwords, right? So basically I'm giving that from English, I want to see the stopwords. So what are these stopwords? These stopwords are used as a bridge in languages basically. In case if you take English, so these stopwords may not carry any meaning over here, but at the same time, like if it is not there, it may not nice to look at those sentences. That is the reason it is being used as a bridge in all these sentences. So what I'm doing, I'm getting for English, right? So from NLTK dot corpus import stopwords. So I'm getting stopwords from English, right? So once it is being done, I have to remove the stopwords now. So again, what I'm doing, I am creating stopwords and empty list. And for W in no punk, basically no punk in the sense like we have removed the punctuation. If W not in stopwords, stop underscore words append W, and I'm printing all the stopwords, right? So what is happening over here? I am getting all those really required, right? So I am getting natural language processing, NLP, field, artificial intelligence. So I'm getting output as 42. So just look at over here, it started with a 485. And finally, now we are getting it as once we do this, no punctuation, it is being converted into this. And this is what we are getting 42, right? So what I'm doing now, again, I'm creating FDist, frequency dist for stopwords, and the most common over here. So what I'm getting, language 3, NLP 3, human 3, natural 2, also 2, right? So this is what being happen now. Now what I'm doing is, like I want to do stemming, right? So let us try to understand what is this stemming. Stemming is, like say for example, I have words like believe, believing, believed, believe. So that may not be really required to have all the words. Otherwise, the number of count or the characters are going to be higher. To minimize that, what I'm doing is I'm using this Porter stemmer. So from NLTK.stem import Porter stemmer. So Porter is equal to Porter stemmer, and then I'm giving the list over here. For W in list, print Porter.stem. So this is the output I'm getting, BELIEV, right? So this is the output I'm getting. So when I do with this WordNet lematizer, Lima is equal to WordNet lematizer, and these are the list. This is the list basically behaving, believe, studies, believe. And for W in list, I'm printing lima dot lematize of this, basically this W, right? So behaving, believe, studies, believe. So what is the difference we can see over here is when you give believe, believing, believed, believes in Porter stemmers, when in stemming, you are getting the output as the same. That's for this case particularly. And like if you consider this word, there is no meaning for this word, right? Basically, BELIEV. In case if it is E, then fine, okay, there is a meaning. But there is no meaning over here. So now you can understand here over behaving, believe, studies, believe. So what are we getting as the output? Behaving, believe, study, believe. So basically what is happening here is everything is converted into the root word which is having the meaning. So similarly, the next one what I have tried is from NLTK.stem import WordNet lematizer. And here I have given the list as where, was, are, am, right? So it is trying to identify this basically, and I'm getting output as BBBB. So what does this mean basically? So what is happening here? So this where was R am. So everything is almost the same word which is equivalent to BE. That is why we are getting as the output, right? So in case if you want to do POS for the same, what you will get for believing studies teacher. So if you get that, believing you are getting it as VBG, verb and gerund. And here studies, you can get about noun singular, and teacher also we are getting as plural, right? So this is how basically this technique work. So in this video, we had a discussion regarding how to tokenize into sentences or the words. And also we tried to understand, we tried to convert it into lower, right? So when I used this lower, what happened previously, it was in capital N, now it is changed into a natural C. Because why we are doing this? Because in some sentences, artificial may be the first word, in some cases it could be in the middle. At that time, it should not consider both as a different term, right? So that's the reason it is being done. And then we remove punctuation. And then we have seen how to use this stemming and lemmatization. Hope it is very clear. Sentiment analysis. So have you ever heard this word sentiment analysis anywhere? Okay, say for example, you are purchasing a phone or a laptop from specific website or from a store, okay? So whenever you purchase a product, if you are really happy with the product, you may go and write it in the website or in the specified forum about that particular phone or the product, whatever you purchase, right? Even in case if you do not like it also, you may write about the feedback in that provided forum. Now, you are a customer over here. So just think from the business person point of view. He should know whether he is able to please the customers, whether he is able to make the customers happy, or the customers are not really happy with the product, or else the business people want to know whether they have to improve on any point of view, right? So this is where the sentiment analysis pitch in. Whenever you write some feedback or the comments or the reviews on the forum, the business people will try to understand whether it is a positive statement or a negative statement or a neutral statement. Right. So what is sentiment analysis? Sentiment analysis is a supervised machine learning technique that is used to analyze and predict the polarity of sentiments within a text, either positive or negative. So we may be wondering what is this polarity? So polarity for now, just you can think that whether it is about positive or negative, right? So it is used by the companies and the business people to understand their user experience, emotions, responses, so that they can improve the quality and flexibility of the products on the services, right? So how this can be done? So first of all, we need data about the feedback, right? So we all know that data is the heart of every machine learning problem. So in terms of machine learning, no problem can be solved without the data. So we are trying to collect the data from the forum, right? So let's try to understand the pipeline in sentiment analysis. Whenever we handle any task in machine learning, we follow certain pipeline, right? So here the first pipeline is that pre-processing text and building vocabulary. So here we will be trying to remove these stop words, punctuations, URLs, and any special hashtags, which is not really giving any meaning or values to that particular model, right? And then adding unique pre-processed words to your vocabulary, right? And then the second step is about feature extraction. So this will be iterating through each and every data example to extract the features using a frequency dictionary, and finally create a feature matrix. The third step is the training model. So now we will be using the feature matrix to train a logistic regression model or any model in order to use that model for predicting sentiments. Then it is about the testing model. So using our trained model to get the predictions from data it has never seen, right? So the first step, what I said, was about pre-processing data. So we all know that this is the most important and crucial step in the pipeline, because this is the most important thing that's going to add value to the model, right? So pre-processing takes first step is, say, tokenization. Tokenization means what? Say, like the person will be writing the feedback in a sentence. It is basically an unstructured data. So the sentence has to be broken into words, right? So that conversion is basically called as tokenization. Tokens means words over here, right? And then we will be trying to remove the URLs. We'll be trying to remove the stop words, say, then punctuation, stemming, lower casing, and all, right? So let me tell you, say there is a statement, right? The movie was awesome. And the person is very much excited, and he has used this exclamation mark also. So what will happen in the first step? What do we say? Tokenization. So what will happen? It will get converted into tokens. So the movie was awesome are the tokens now, right? So the next step that URLs and handles, no URLs over here. Stop words can be removed. So what are the stop words? The can be removed, was can be removed, and then when it does punctuations, this can be removed. So we will be having only these two. Excuse me. We will be having only two words over here. One is movie and the next one is about awesome, right? Right, we have only these two, movie and awesome. Then stemming means like, okay, here the stemming is not really required. Lower casing means like, okay, anyways, it is being removed already, right? So this is how the pre-processing the data is being done, right? Right, so this is how the pre-processing is being done. Then the next step is that after pre-processing the data, we have to create a vocabulary. It could be bag of words, or it could be bag of words, or basically just to create vocabulary that will store each word and assign some numeric value to each distinct word in the sense like the tokens, right? So we all know that machine learning algorithms cannot work on the raw text directly. So we have to use some feature extraction techniques to convert text into a matrix or vector of numerical features, right? So it's a naive approach to extract features of a text. So according to this sparse representation, we can create a feature matrix by iterating through the entire data. And for each word in the text example, we will assign 1 at the position of the word in the vocabulary list. And for non-occurring words, we will assign 0. Okay. So for feature, so our feature matrix will be having rows, which is equal to total sentences in our data, and columns equal to total words in the vocabulary. So actually, what are we doing? After pre-processing the data, we create a vocabulary that will store each unique word and assign some numeric value to each distinct word, right? So this is what happening. So while working with the language processing, there could be another problem is handling the raw text directly. So that is the reason we are going ahead with this feature extraction techniques, right? And then like we have seen about sparse representation, and here the disadvantages of this is actually it may require large training time, and the prediction time could also be larger, right? So like in the feature extraction, the positive frequency means what? The number of times a word occurred in sentences with a positive sentiment, and the negative frequency is being done the number of times a word occurred in sentences with a negative sentiment, right? So a frequency dictionary keeps track of the positive and negative frequencies of each word in the data, right? Say, for example, the sentence, I'm happy. So it will be trying to identify in how many places it is being positive it is being positive, and how many places it is being negative, right? So here, using frequency dictionary for feature extraction, we can reduce the dimensions of the each row, by representing each sentence on a feature matrix, right? So features of a text data are extracted with a feature dictionary using this following formulae, right? So you can see that xm, which is equal to 1 summation frequency, right, w comma 1 frequency w comma 0. So this is basically the features of tweet m, and this could be the bias, this could be some positive some pos frequencies, which means some of positive frequencies, and this could be some of negative frequencies, right? So this is what will happen. Now what will happen for the words in the vocabulary, the positive frequency, negative frequencies will be noted. So we will be having no we will be having the three-dimensional feature vector for a single tweet, right? So we will be having dimensional feature vector for our tweet, right? So now we have to iterate through each and every example to extract features of each example. Then we will be using those features to create the feature matrix, right? So now here you can see that this is how the model is being trained, right? You can see that initialize the parameters, and we will be initializing our parameter theta that we can use in our sigmoid. So here I have, in case if we are using logistic regression, we initialize our parameter theta that we can use in our sigmoid. We then compute the gradient, right, that we will use to update this theta and then calculate the cost, right? So we will keep repeating the steps until the cost minimizes or converges, right? So this is how the model is being trained, right? So how to test the model now? Okay, so how we will be doing the testing the model now? We have to split the data into X validation and Y validation sentiment, then use feature extraction for this X underscore validation to transform text into numerical features, and find the vector H is equal to sigmoid for each text in the validation set. Then map some function to get the actual classes while comparing with the threshold. Then we can find the accuracy of the prediction. So accordingly, we can find out the sentiment, right? So this is how we can do the testing of a model, right? So now let us see how we can use it, how we can do it using algorithm. You can see over here, I have like from text blob, import text blob, right? And then I have written the first sentence, test 1 is equal to text blob. I have written the movie was awesome, right? So when I try to test this sentiment, it is returning me polarity 1, subjectivity 1. So polarity is 1 means it is a positive statement, and also subjectivity is also saying that it is 1, right? And then I'm trying with the movie was terrible. This is very easy. Even someone, when a person here also, he can understand that it is a negative sentiment, right? The same thing, the machine is also identifying that polarity is -1 and subjectivity is 1, right? Say for example, I'm writing like this, the movie is not that good. Okay, the movie is not that good. So in this case, the polarity is being taken as 0.875 and subjectivity is taken as 0.6, right? Then the fourth statement, what I have tried is, I think he went to temple. So here the statement could not predict anything related to the sentiment, right? That is why we are getting it as 0. And the next one, the food served at the park was great. The park was great. Okay. So let me run all these sentences once again. So when I say that the food at the park was great, now I'm getting polarity as 0.8 and subjectivity as 0.75. So let me make it to not great. Now you can see that the polarity is changed to -0.4, which means it is a negative sentiment. Hope I'm very clear with this positive and negative sentiment, right? So first of all, you have to understand why sentiment analysis is really important in business point of view, because all the businesses are dependent on the customers. So we actually value the customers' feedbacks and the reviews. So this sentiment analysis is going to be a very important task in the field of NLP, right?